How does cannabis affect neurotransmitters? Have you ever wondered how cannabis interacts with our brain? Understanding this connection can help us grasp the complexities of addiction. Cannabis primarily affects the brain through its interaction with the endocannabinoid system. This system plays a vital role in regulating neurotransmitter activity. The main psychoactive component in cannabis is tetrahydrocannabinol, commonly known as THC. When THC enters the body, it binds to cannabinoid receptors, particularly the CB1 receptors. These receptors are found in areas of the brain that control cognition, memory, reward, and mood. When THC activates these receptors, it changes how certain neurotransmitters are released and absorbed. One of the key neurotransmitters affected is dopamine. Dopamine is crucial for the brain's reward system. Initially, cannabis can increase dopamine releases, leading to feelings of euphoria. However, with long-term use, cannabis can reduce dopamine function. This reduction may result in symptoms like anhedonia, which is the inability to feel pleasure, cognitive decline, and a lack of motivation. Another important pair of neurotransmitters influenced by THC are glutamate and gamma-aminobutyric acid. Glutamate is an excitatory neurotransmitter, while gamma-aminobutyric acid is inhibitory. THC disrupts the balance between these two, which can impair synaptic plasticity. Synaptic plasticity is the brain's ability to adapt and learn. This disruption can harm memory formation and cognitive functions. Acetylcholine is also affected by THC. Acetylcholine is vital for memory and attention. The interference with acetylcholine transmission can explain the short-term memory issues often seen with cannabis use. Additionally, THC modulates other neurotransmitters like noradrenaline and serotonin. This modulation can further impact mood, stress response, and cognitive processes. The interaction of THC with the endocannabinoid system disrupts the fine-tuning of synaptic activity that endocannabinoids usually provide. This disruption can impair the connectivity and functioning of neuronal networks, especially in regions like the hippocampus and prefrontal cortex. These areas are critical for memory, decision-making, and self-control. Chronic use of cannabis, particularly during adolescence or young adulthood when the brain is still developing, can lead to neuroanatomic changes. These changes may include reductions in gray matter volume in key brain regions. Such alterations are often linked to cognitive deficits, including issues with working memory, attention, and executive function. Interestingly, some cognitive effects may improve after a period of abstinence from cannabis. This suggests there is potential for recovery of brain function. From the perspective of substance abuse and addiction, understanding how cannabis affects neurotransmitters is essential. These changes can contribute to the development of cannabis use disorder. This disorder is characterized by compulsive use despite negative consequences. By grasping how cannabis interacts with neurotransmitters, we can better understand why some individuals develop dependence and how cannabis use can lead to lasting changes in brain function and behavior.